Okay, so we're going to do the same steps as we did before. We need to find our center, which is going to be at 7.5. We need to find our focal point, which is going to be about 3.75 or 3.8. So here's our center, and here is our focal point. So we're going to have our object again, which is 3 centimeters high, but in our first scenario, we had it outside here, outside the center. Then what we did is we were approaching the focal point. It got larger. So what we're going to do is we're going to have a couple scenarios that we're going to be drawing over here, and we're passing now the focal point. What happens when you pass inside the focal point? What's going to happen to your image? So let's go ahead, and we're going to maybe measure about, we'll say 2 centimeters away from the focal point. Okay, if you can draw now your object, which is going to be 3 centimeters high. Okay, so we have our first ray coming in parallel to the principal axis, as before. Coming in parallel. This is then going to do what? It's going to exit through the focal point. Okay, so it's going to exit through the focal point like this. Oops. That's our first scenario. So now, let's take a look at the second one. We have to draw our incoming ray that's aligned with the focal point. However, if we just drew this right here through the focal point, that incoming ray, or the incident ray, is never going to hit the mirror. So we can't draw the line going down like this. However, we can draw it going upward, aligned with the focal point. So when you're on the inside of the focal point, we have slightly different rules. We have to align the top of the object with the focal point. Do not draw the line downward. We're going to draw the line upward so that it hits the mirror. So our first ray came in parallel, exits through the focal point as normal. Our second ray lines up to the focal point, but it has to enter into the mirror, and therefore it's going to be reflected out parallel to the principal axis. Okay, so that's our scenario. And you might say to yourself, wait a minute, these two are never going to converge. What's going to happen? Well, what we have to do is, this is going to be not a real image where the light rays converge, but it's going to be a virtual image, just like a plane mirror. Okay, so I'm going to turn my paper a little bit, like this, because what I need to do now is I need to trace the reflected rays backward with a dotted line. These are called, again, the sight lines. So I have a sight line that goes like this, and I have a sight line that goes like this. Where they converge, that is where let's extend this principal axis a little bit. Where they converge, that is where the image is going to appear. So if a concave mirror, if you're outside of the focal point, you're going to have a real inverted image. However, if we are inside the focal point, we're going to have a virtual, and the opposite of an inverted is going to be, just like with light waves and other waves, is going to be an erect image. So let's see what happens if we go a little bit farther away from the focal point. This was about 2 centimeters. Let's just go maybe 2.5 centimeters like this. Okay, I'm going to do this with a different color just so that it's a little bit less confusing. We have the same height, so it's going to be 3 centimeters high. We're going to see what's going to happen to this as it gets closer and closer to the mirror. So what's going to happen with this is my first ray is going to come in parallel to the principal axis, which means that it's going to have the same effect as this right here, and it's going to go out like this. It's going to have the same first reflected ray as if the object were right here. The second one is going to be a little bit different though. So let's go ahead and draw this, line up the tip to the focal point, and we're now going to draw this out toward the mirror. This one is then going to exit parallel to the principal axis. If you want, we can go ahead and draw the first one as well, coming from here and then exiting out there. Okay, so something very similar is going to happen. These lines still will not meet with each other. So we need to create sight lines and see where those are going to cross. Well, if we follow the sight lines from the reflected ray, just like a plane mirror, this one's going to be going back like this, and then this one will be, sight lines will be looking like this. Those will meet right there. But what's happening to my image? My image is still erect, but it's a little smaller. Because if you remember, as we approach the focal point, the image gets larger. If we started with this one and we approach the focal point, the image, which is a virtual image, would get larger as well. So when you pass through the focal point, the image becomes erect. That's the first thing. When you pass the focal point, the image becomes erect or upright. Oop, we lost the light. The image becomes erect. It also gets closer, so this is one point. The closer that you are to the focal point, the larger that it's going to be. Closer to focal point will equal a larger image. But in both of these cases, take a look at the size. Here is the height of the object. We'll just say 1. Here is the height of the image 1. Height of the object 2 did not change. Height of the image 2 is a little bit smaller, okay, again because we're getting farther away from the focal point. However, both of these are larger than the actual. So in this case, when we're on the inside of the focal point, we will always have a larger image. You'll see both of these are larger than the original. So we have a larger and we have a virtual. We have a virtual because our sight lines converged and not the actual rays of light themselves. And they will be upright or erect. What is a practical feature of this type of mirror? This actually is your compact mirror. For ladies, when you're, whatever you do with your makeup or plucking your eyebrows or whatever, if you have that little curved concave mirror, Okay, the focal point of those mirrors are very, very far away, so that when you bring your face in toward the mirror, it's going to make your image appear larger. So it acts as sort of a magnifying glass. Your image gets larger, it gets magnified with this concave mirror because your focal point is so far away. Whenever you pass through that focal point, you will then see a larger image of yourself.